Hi everyone, my name is Gautami and I am happy to discuss our paper Can Neural Networks Learn the Same Model Twice? Investigating Reproducibility and Double Descent from the Decision Boundary Perspective. This is joint work with my colleagues Liam, Arpit, Peng, Yehuda, Micah, Professor Boraniak and Professor Goldstein. With new architectures being introduced every day, it is important to understand how stable the models are and how introduction of each layer modifies the decision boundaries. To that end, we asked these two questions. Do neural networks learn the same model twice? Do different neural architectures have measurable differences in inductive biases? We also studied the deep double descent phenomena in ResNet models and looked at how the decision boundaries are changing as we traverse the double descent curve. Before we move forward, let's see what I mean by decision region. It is a small slice of plane which passes through three random given images. We interpolate and extrapolate and predict the majority class for all such points. For example, here we see one such decision region generated from a random airplane, frog and bird images, and we see the corresponding predictions on a DenseNet model. This brings us to our first two questions about reproducibility and decision region similarity. In this plot, we show many decision regions for a randomly chosen triplet in CIFAR10 dataset on various architectures. Each row corresponds to a model trained with a different initialization and each column corresponds to different architecture. For fully connected net, even the predictions on the data points are not consistent. For bigger models with the stronger inductive biases, we see consistency in the predictions around the sample data points as well as the points further away in the plane. So we proposed a metric to quantify the consistency in decision regions across different training runs. We call it the region similarity score. It is a very simple idea. It is nothing but the intersection over union of predictions of all the points in a given decision region. For example, here we see decision regions for the same triplet for two differently trained ResNet 18s. We compute the intersection in predictions of all these 10,000 points and divide them by 10,000. We compute the score as expectation over many such decision regions of random triplet. In this heat map, we show region similarity scores for various architectures. Diagonal elements reflect how reproducible the models are, and off-diagonal elements show how similar different architectures are with each other in terms of decision regions. A few interesting observations. Wider models are much more reproducible. Residual connections do not change the decision regions drastically. If we compare DenseNet and VGG with a ResNet 18 model, we see the similarity scores are very close to each other, hence showing residual connection is a weaker inductive bias in terms of changing decision regions. Despite sharing a bunch of similar type of layers, VIT and MLP mixer are very different models and are not similar to each other, nor they are to any other convolution models or any fully connected networks. In this slide, we see how the test accuracy and region similarity scores change with respect to optimizers. Couple of interesting observations. SAM always resulted in higher similarity score for all the architectures, even though it did not result in the highest test accuracy. MLP mixer have lower reproducibility score compared to the VIT, despite of having higher accuracy. This shows that models with the high accuracy does not always have the highest reproducibility. In this slide, we present some knowledge distillation results. To the left, we see the region similarity scores of teacher and student, and to the right, we see the teacher model and vanilla trained model with the same student architecture as control case. Across the board, the distilled students exhibit a higher similarity to their teacher compared to their vanilla trained counterparts. Another interesting observation is, across all the models, we see the higher similarity when teacher and student have the same architecture, except for VIT, which somehow has the lowest region similarity when the student and teacher are the same architecture. Please check out our paper for more interesting discussion. In the interest of time, I will not be discussing the deep double descent results here. Please check out our paper or visit our poster to understand this phenomena. Hope you enjoyed our paper. You can find the code and the link to the materials at this page. If you want to learn more or have any questions, please visit our poster. Thank you.